All right, good evening. My name is Dan Singleton. I'm the CEO of TPS, and I'm excited to tell you about an amazing opportunity we have with our technology. Our technology has demonstrated over a 20% increase in fuel economy in natural gas and gasoline vehicles. In addition to this approach, we've also seen more than 50% less NOx emissions coming out of the tailpipe by applying our technology directly at the end of the exhaust. The opportunity for this is enormous, from cars to racing, motorcycles, buses, and trucks. So how do you get a transformational technology like this into the marketplace? We focused on markets that had time-critical needs with no alternative solution. So the immediate market we're looking at is trucking. The economics of trucking is changing. The rising cost of diesel fuel has forced truckers to look at alternatives. The average truck owner is spending $45,000 a year on diesel fuel. They look at natural gas and they see that it's significantly cheaper per equivalent gallon, and the price is forecast to be much more stable. It's available here in the U.S. So if they convert their large truck to run on natural gas, they can save up to $20,000 a year on fuel. So the question is, why aren't they doing this? Well, it turns out natural gas is very difficult to ignite. The ignition temperature is more than twice that of diesel fuel, and so it's very hard to get stable combustion inside of this engine. But you see natural gas vehicles on the road, right? You see buses, you see little Honda Civics. So what are they doing? Well, the OEM approach for big trucks, Cummins and Westport are taking this approach, is dual fuel. You spray a little bit of diesel fuel in the cylinder, it gets things hot, then you can spray in the natural gas and it will ignite and burn. That way you can get the efficiency of the diesel engine. Problem is now you have two fuel systems, it's expensive, it takes years to pay back. And you also have to have additional exhaust after treatment, which requires fluid replacement very frequently, increases maintenance cycles. The other option is high energy spark. So now you want to run your diesel engine like a spark ignition in a car. Well, to do this, you have to increase the spark energy by up to a factor of 10, and you have to reduce the compression, reduce the amount of power the engine can produce. So two things happen. Spark plugs melt, and you don't have the torque to carry your goods up a hill. You don't have the range to get to the next fueling station because the infrastructure is not there. TPS solves this problem with our innovative low-energy approach. What you're looking at is a video on the left of high-energy spark, the existing technology, igniting natural gas in a chamber. On the right-hand side, you're seeing our technology. So you can see a significant difference. We can very easily ignite natural gas at high pressures, and you can run the engine just like a diesel engine. So how do we do this? Well, if you look at how spark works, you dump the energy into producing heat. It's like sitting there and holding a match to the flame. And then that heat goes into the fuel and causes a chain reaction. The amount of power in this discharge, the peak power is about that of a scooter. What we do is we take that energy and we compress it into 1/1000th of a second. And when we do that, the peak power is now that of 4 locomotives instead of a scooter. But the energy is very tiny, and so what you can see here is that it actually volumetrically ignites the fuel. All the energy goes directly into the fuel air instead of into heat. So we started this company in 2009. This was 4 PhD engineers and physicists from USC. The technology was developed over the past 10 years with over $10 million in funding from the DoD, and we formed the company in response to a pull from the marketplace. We were working with aerospace companies, with the Department of Defense. They wanted these devices to continue research for advanced engine concepts. So we started the company to sell those devices. We've been cash positive and profitable since our inception. We now have Air Force grants, state grants for looking at natural gas. That's how we funded ourselves and grown up to this point. Since forming the company, we've added some extremely strong team members. Dr. Mike Mann was a senior executive at Northrop Grumman, he's sitting right here, and was also the CEO of both public and private companies, and brings tremendous business acumen to our company. And we recently added to the board an automotive advisor who is a senior executive at Fiat Chrysler, as well as Dow Chemical and Federal Mogul. So our immediate market is exploding. There's forecasted to be more than 35 million natural gas vehicles on the road by 2020. And if you look at the makeup of that road as the plot works, you'd see that this big green plot right here is actually CNG trucks. It's expected to take over the market in the next few years. We currently have a contract with a strategic partner worth $75 million in annual revenue by 2018 to the sale of these ignition systems for retrofit kits that convert diesel engines to natural gas. So this market is really exciting and it's exploding, and this is where we want to start. What we're really trying to get to is, again, the plot's not working, but what you can see here if the plot was working is that over the next 20 years, the majority of the fuel consumed is still going to be gasoline. Natural gas only makes up 4% of the energy consumed in transportation. Gasoline right now is 60 and is forecasted to be 50 out in 2040. So with a small win with an OEM such as GM and Ford, which we've already initiated discussions with, 200,000 TPS systems, we're looking at revenue that dwarfs our revenue in the natural gas space by 2018. So the numbers that you see here for natural gas are actually contracted values. This is a number with a contract, in a contract with our strategic partner. In addition to committing to buy the systems from us, they've committed $2.1 million in non-recurring engineering funding to make sure that our system developed fits into their system. They paid $500,000 of that up till this point. Our real target is to get into the automotive ignition world. This is a long lead time market. It takes a while to get into it. It's very conservative. So we're starting early. We're starting the meetings now. We had a meeting with the CTO of GM recently, and we're targeting to get those systems out in mass production by 2018. One market which I didn't talk about very much yet is the emissions treatment. We can apply this technology directly to the exhaust. We're working on this as well. We've done a demonstration for a customer recently where we put this on a Tier 3 engine that needed to get up to Tier 4i standards. We're able to decrease the emissions coming out of that by 80% with our non-thermal plasma technology. That technology requires no fluid replacement like the existing technology does. So our strategy is to focus on technology development while developing strategic partner relationships. So our core expertise is nanosecond pulse power. This is what we're good at. We have 14 patents, half of them or most of them from the university, and a few patents that we own entirely on our own. And we're focused on building the company around that tech. So we're looking for 10 million, 2 million now, and 8 million once we reach our alpha prototype to get us to mass production for the ignition systems that can be applied to both CNG and gasoline engines. And the exit for this technology is a licensing or a merger acquisition in the field of use of transport. So this technology has many other applications, including a cancer therapy that we're currently in FDA trials with, as well as improving the quality of wine. So this is a real platform technology. We're looking to improve fuel efficiency and reduce emissions and transform transportation. Thank you.